Hi, my name is Sam Lau, and my project is called Regression, Explained Visually. Suppose you're trying to learn about regression for the first time. You might go to Google and ask, what is linear regression? The first result is Wikipedia, so let's go there. And if you go to the first page on Wikipedia, you get a bunch of explanation, and then you'll immediately get hit with a bunch of equations. You won't get an explanation of what regression actually is, or what it's useful for, or when it's not useful. On the other hand, you might go to a textbook. If you go to a textbook, however, what you'll probably get is just pages and pages of equations and math, and again, it's really hard to develop an intuition for what regression actually is through a textbook. In my project, I take an interactive, engaging approach to explaining regression. I start off by briefly explaining what regression is useful for, and then I give the user the opportunity to play around with it. Here, I have a regression line fit to a couple of points. If I drag these points around, the regression line updates immediately. In addition, I can see that the dataset on the right-hand side updates and the colors correspond, so you can see exactly what you're doing. I can ask myself questions during this process. What happens if the points are clumped together? What happens if all my points are sloped up instead of down? The reason why I can ask these questions is because I can get answers immediately. I then go on to explain the notion of error, and then continue on to polynomial regression. In this case, I'm trying to predict the ice cream's overall rating based on its sweetness. It makes sense that if ice cream is way too sweet, you probably won't like it. And if the ice cream is not sweet enough, you probably won't like it either. In this case, fitting a line is not really sufficient. What you want to do instead is fit a curve. But what kind of curve? Well, you can fit a nice little quadratic curve here, or you can keep going and fit a degree 5 polynomial. How do you decide whether a degree 5 polynomial is better than a degree 2 polynomial? Well, one way you can find out is by dragging the points around. You'll see that the degree 5 polynomial jumps around really wildly, but the degree 2 polynomial stays mostly the same. That gives you an intuition for how regression behaves, and it gives you an intuition for understanding why a degree 5 polynomial is not that great. I then continue to talk about the difference between training error and validation error, and how validation error is the one you actually want to use to determine which degree polynomial you want. I then conclude with a discussion of this notion that the validation error typically goes down and then up, and that concludes my project, an explanation on regression.